Hello, this is Steve from ObjectRiver. Welcome to Part 2 of ObjectRiver's Angular implementation of REST web services. This part is really more a detailed view of the example that you saw in Part 1. So let's start. If we start, we just look into just a refresh. We'll look at the model that we have here. An enumeration, a couple of beans, and then basically three web services, all described in a JAX-RS-like metadata language. If we think about the pages you saw, and we'll go through there, there's really just 5 pages, and let's go to the web server to see those. Your first page that you saw was really the overview page. This is the documentation of your web services and the way you want to invoke them. You see the 3 web services. The previous Part 1 executed this beanless round-trip web service, and at the bottom you see the definitions of the beans and the enumerations. If we go to invoke, you'll go to the request page. So this is the request page for making a web service, and at the top there's actually an endpoints page. The compiler generates a list of endpoints that then you see in a list here. And so what we're doing is we're combining endpoints with the request page, and this is something Angular can do. You can make multiple pages to displayed in a single page. If we execute this and send the web service, what you're seeing is the response page. Okay, so that's like the 4th page that we built. The only other page is called a message page. I'm going to go back to Intellij, and we're going to go to Ant, and we're going to stop our web server here. So we're stopping the Docker implementation of the beans service. So this will give us an error. If we go back to the page, now we're going to do a send from the request page. And what happens, you get an error. Now what you see is this error message, and this is a page. This is modeled after Salesforce. Salesforce has a page message page, and what we've done is we've created this page, and it's invisible unless there's an error or some kind of information. So those are the 5 pages that make up this application, and so but for each web service you'd get another request and response page. So let's look at the code. We're going to start with the TypeScript, and so if we drill into our let's do the one we did here, the beanless round trip. This is the request, and under it you see the response. Now there's basically 3 TypeScripts. You have the request TypeScript, then you have the service TypeScript. The service TypeScript is what we'd call in Java a singleton, and it stores state. And in this implementation, the service TypeScript handles all of the web service implementation. You can actually take this and pull this out of this application, and you could use it in your application. And then we have the response page. So let's look at these things. If we look at the request page, let me get a little more real estate here. If we look at the request page, you'll see that it's importing the types from this shared models directory. So here we have 2 beans and enumeration. Let's look at these first, because this is where we're using the TypeScript JSON to TypeScript package. So if we go into shared models and we open test bean, now what you're seeing is you're seeing the implementation in TypeScript, but it's using TypeScript annotations here. And this is part of the JSON to TypeScript package. And so what you're seeing is this is a bean class which they're calling a JSON object, and it has properties. And so you're seeing that member1 is an array of string and member2 is a number. If we go to bean list, you're seeing that enum list has this converter type, and we'll look at that next. And bean list is an array of test bean, as you can see. Now let's go to the enumeration. Here's the enumerated type. You'll see this straight up enumeration, but then you'll see this converter class, and this converter class has two methods, serialize and deserialize. And in this implementation for enumerations, it handles arrays as well as regular enumeration, so it tests for arrays, and the same for deserialize. Now the reason you have these classes and we're using this JSON to TypeScript package is that when you say retrieve from our method and it comes back with an object containing objects and lists and enumerations, those are just in basically JavaScript objects with no types. And what you'll see is we're going to use this JSON to TypeScript package to marshal those back into true TypeScript classes. So if we go back to our request, you see it brings in these types. It defines an Angular component, and here's the component, and all of our input is here. We have one input argument, and this is the arg, and it's a test bean list. The other thing we're doing, and you'll see this further on, is we're creating a map here, and the map maps a string to a function. And in the constructor, what we're doing is we're mapping the name of the bean classes to their class name. And in TypeScript, when you have just a class name of a bean, that ends up being a constructor. So this map is actually a map of strings to constructors of beans. In OnInit, we check if the response is not undefined, which means it's defined and this has previously gone through a web service. So you made a previous web service of this, and the state of the arguments are stored there. So it remembers your previous arguments, and this happens in the OnInit. If you look down here, we have two methods, and these are generic methods for adding list items and deleting them. And you can see you're passing in the list from the page and its value, and you're pushing it onto the list. And you can delete them in the same way, and you'll see these calls from the HTML. Also has a generic add bean item. Now this is where we're using the class reference. So when you say add bean item and it comes from the page, the class reference is just a string. And so this is where we do the lookup of the string class reference and map it to the true constructor. So by saying new and adding these parens, we're actually constructing a new bean and pushing that on the stack. So this is a generic add bean item to allow us to add beans classes to the implementation. The other things we do, you see these track bys. Track bys are a way for the ng4 statement to keep track of mostly primitive objects. And so if you've ever built, if you're in Angular and you have a list of things and you're doing an add or change things and things are getting a little crazy, it's because you haven't had the track by, and Angular can't keep track of which instance member it has. So these are generated. You see we had one for the enum list, one for member1, which was a string, and this is a generic one for bean lists. If we go down here, this is for enumerations, and this is saying add an enumeration type. When this comes in from the when it comes in from the page, the value is deserialized and pushed on the stack as a string. And here you're seeing we're using the converter. The next thing, here's the invoke, and this is connected to the send button. In this case, there wasn't any header params in this application, so it's just newing an empty array of headers. But here you're calling, now we're calling the service, and the service bean list round trip, and we're passing the input argument with the headers. This final one is to get the result back for the actually for the response page, and you'll see that called later. So let's go to the service. Okay, we go to the service. You see bringing in the Angular types. We're bringing in the converter from JSON to TypeScript. And here's the two other pages we use. That's the endpoint page. This is the page message page. And we're bringing in the test bean list object. All of our code, even if it's in the pages and whatever, you're going to see a description of the web service. So whether you're in TypeScript code or HTML or any of our, and it's related to a web service, you'll see a signature comment here for your reference. So here's the service. Here's the input arguments. So we have a copy here. This happens to be just a local URL string. And then here's the result. So in this example, we passed in a test bean list arg, and we're returning a test bean result. Here's the constructor, and we're initializing certain bunch of the services that come in. There's a clear message page. This takes down the message from the main page. And here's our web service request. So we're requesting, we're sending in the arg and the headers. Here we're instantiating a converter and saying we want it to log and we want to support null values. Here we take the arg and we save it inside the service. This is how we store that state. So if we're in the response page and we go back, when we go back to the request page, we have the previous state. Here it is constructing the URL. Now, this is similar to the beans in the shared models. So for all the in arguments that are not like web parameters, they're in the body, we'll create this inner class called indoc. And this class will define all of the in arguments. So here you're saying we're defining this arg, and it's of type bean list. And then in the constructor, we're doing that assignment directly into this indoc. So this is the value that we're going to pass to the converter. And you see we have right here, we're instantiating a copy of indoc. Now, the other thing is this data will be converted from TypeScript classes and TypeScript enums to JSON. And so we're calling the post method, and we're sending that body over to the Docker server. And we're saying the response type is JSON. Okay, so this is important. So when it executes and now we get a 200, it's coming back, and we get this body statement. This body statement is not JSON. It's already been marshaled into JavaScript type objects, classless objects. And so by using the converter here and saying deserialize objects and then passing in, remember this is a constructor to the test bean list. now the result will actually contain all of the TypeScript classes, beans, enumerations, etc., because this JSON convert deserialize object is capable of doing recursion through your response object and correctly, instantiating the objects. And the last thing we do is we navigate to the response page. Before I go there, we see this 409. ObjectRiver kind of has a standard. If there's an exception thrown on the server side, we'll return a 409. And in the 409 will be a status, a message, and a trace, and that can be displayed in the message page. Alright, so let's go to the response. We go in here. The response is nested one level below the request, and we can go in the response class. Pretty simple. It's bringing in the models that it's concerned with. You'll see it has a signature here so you can tell what's going on. And the only thing really it does is it assigns the result from the service into this result class. So now when I get in the page, the result page, it's there. So that's in a nutshell, that's the pages that we have, the 5 pages, and then really the TypeScripts that you're concerned with are the request, the service, and the response, and how they interact with the pages. The only other thing I want to show you is this. For this whole demo, we've been using Intellij, but there's also another product from JetBrains called WebStorm, and you can actually open the same project in WebStorm that's in Intellij. They're the same, but you pay for this one. I pay about $13 a month for WebStorm, but what you get from this now, in addition to the color coding, is you'll get syntactical errors from this, and you can hotkey to different classes. And it's the same for the HTML that you might look into. You can even get syntax errors in that because it understands Angular also. So this is key. If you're really going to dig deep into this, you should probably look at getting this WebStorm. So what I do is I run the free version of Intellij, and then I run like a $13 a month version of this WebStorm. So that's it for the kind of detailed view of our Angular implementation. Thanks for watching.